If we are given the equation of a line, one of the things we can do is to use that equation to determine a second line, which is either parallel to the original or perpendicular to the original. In this example, we'll see how to take an equation for a line that we know that we're given, and to determine an equation for a line which is perpendicular to it and which passes through a point which is also given to us. First, we have to take a moment to think about what our goal is. As with any problem in which your result is the equation of a line, let's make our goal to be an equation in slope-intercept form, y equals mx plus b. That means that once again, our job is only to determine two numbers, the slope of our line and the intercept of our line, and then to place those two numbers into context in the slope-intercept equation to finalize our answer. Now that we know what the goal is, let's take a moment to understand the line that we've been given initially in our problem. To do that, let's pay special attention to the slope of that line. The reason we focus on the slope in this line and actually are going to ignore the intercept altogether is that the question of how to make a line which is either parallel to this one or perpendicular to this one is really a question of direction. Which direction should our new line go in? And the direction that our new line goes in should be determined only by the direction of the original line that we've been given. So what is the slope of the line that we've been given in this problem, y equals negative 4x plus 9? To answer that question, let's simply observe that this equation has been already provided to us in a format we recognize. It looks just like y equals mx plus b, where m, the coefficient of x, plays the role of our slope. And so, the slope of the given line in this problem is negative 4. Because that's the slope of the line that we've been given, the line that we've been given goes in a direction which is determined by that number, negative 4. Now let's think about what the slope of our new line should be. And in particular, how should our new slope be related to this old slope? The answer to that question depends on whether we're trying to determine a new line which is parallel to the original, or whether we're trying to determine a new line which is perpendicular to the original. In the case where we're trying to determine a line which is parallel, we will use the slope which is exactly the same. Parallel lines have equal slopes to one another. In the case where we're trying to determine a line which is perpendicular, the slopes of our two lines need to be different, and they're different in a way that's described by the opposite reciprocal of the original slope. In other words, we will change the sign of the slope and also flip the slope upside down into its multiplicative inverse, or its reciprocal. So if this problem had asked us to determine a parallel line to the one that we were given, we would observe that a line which is parallel to our given line would have a slope which is the very same as the original. In other words, the slope of a parallel line would be negative 4. If the problem is asking us to determine the slope of a perpendicular line, we'll use the principle of opposite reciprocal to determine that slope. If our original slope was negative 4, then we wish to first take the opposite of that, which means changing its sign from negative to positive, but then also the reciprocal, flipping its fraction upside down to get 1 over 4. So because our original equation had a slope negative 4, a line which is perpendicular to it would have a slope of positive 1 over 4. Since in our example we're being asked for a line perpendicular to the original, 1/4 is the slope that we will use in our final answer. And we're halfway home because we've determined the slope that we need. Now we need only to determine the value of b, the intercept, for our line. As with any problem in which determining an equation for a line is the priority, we can do that by substituting into our equation the coordinates of any point that we know on the line. And we've been given a point, -3, 8, that our line must pass through. So let's substitute -3 for x and 8 for y, giving us only one unknown quantity, b, in our equation, and then solve this equation for b, multiplying 1/4 times -3 to get -3/4, and then getting b by itself by adding 3/4 to both sides. Remembering that to add 8 plus 3/4 will turn it into a fraction addition problem with a common denominator of 4. We find that b is equal to 35/4. So all in all, we've found that the slope of a line which is perpendicular to y equals -4x plus 9 must be 1/4. And if that line passes through the point -3, 8, then its y-intercept, according to this work, must be 35/4. So as always, to finish, we just need to fill in our values for m and b into the slope-intercept equation and obtain our final answer, y equals 1/4 x plus 35/4. So to determine the equation of a line which is either parallel or perpendicular to a line which you've been given, start by understanding the slope of the original equation that you've been given. In this example, we had to observe that the original line had a slope of -4. What you do next depends on whether you're being asked for a line which is parallel to the original or perpendicular to the original. If parallel, keep the slope the same and use that slope in your new line. If perpendicular, take that slope and determine its opposite reciprocal. Flip it upside down and change its sign, either from negative to positive or from positive to negative. Having then determined the slope of your line, the rest of the problem proceeds just like any other problem where you're determining a line's equation. Plug in a point which you know to be a part of that line in the x and y coordinates, and then solve the resulting equation to determine the intercept b. Plugging that b into your equation determines your final answer.